Hi, welcome. I'll be talking about some new tools I've been working on to help with debugging Meteor apps in production. These tools are useful for when an issue comes up in production. We want to understand why, so we can fix it. A little bit about me. I am Mikhail Nissen. I'm a Zodern on GitHub and the Meteor forums. For the past few years, I've maintained Meteor-up, a tool for deploying Meteor apps. And I'm also the owner of Monti APM, a service for monitoring Meteor apps in production to help improve performance, make sure it runs smoothly. Earlier this year, I released Meteor-up 1.5. This was a massive update with many exciting features. It's able to load balance between multiple servers. It can deploy without downtime. It has experimental support for Docker Swarm. It can set up servers faster and deploy quicker. And there's many other improvements, but my favorite one is production debugging. When you develop locally, we have access to powerful tools for debugging Node, but in production, you usually don't have anything like that available. With Meteor-up, we now do. You can run meteor debug and then specify the server name, and it securely connects to the server. It starts debugging in the app, and as you connect your local dev tools to the Node server to the Node server. This gives us many powerful tools. Some of them are CPU profiling. You can take a profile at any point in time for any duration, and then analyze it to see why it's using so much CPU, or understand why the event loop is being blocked. We can take memory snapshots, heap snapshots, or memory profiles to understand why it's using so much memory, to find memory leaks, or understand why there's so much garbage collection. Now, locally, when we debug, we might use breakpoints. They're added to a specific line of code. And when that line of code is ran, it pauses the app, so you can inspect any variables or the stack trace and step through the app to see what each line of code does. But in production, we don't want to use this because it pauses the app. So while it's paused, it's not handling requests from our users. It's not sending updates for subscriptions. So it might be fine for side projects or staging, but for most apps in production, we don't want to use breakpoints. Fortunately, there is another tool we can use called log points, and we add them similar to a breakpoint. They're assigned to a specific line, but instead of pausing the app when that line of code is ran, it instead logs a message. So here we added a log point that logs the collection size message, and then the value of a property. And we can see those logs in the console on the bottom. And then we can analyze these logs and add more log points or modify them until we have enough information to reproduce locally and fix the issue. Now, production debugging is available for Meteor apps with Meteor-up 1.5. A recent update this morning for the Meteor-up Node plugin, which lets you do the same thing with Node servers. And then I'm planning to add this feature to the Meteor-up AWS Beanstalk plugin also. Some companies actually use the Meteor shell protection. Some use it to trigger heap snapshots and upload them to S3. Other companies might run migrations this way. Some use this to debug the internal state of the app to understand why it's not running correctly. But in the past, it's not very convenient to access a production shell. So it's a feature I'm working on. It'll be available in one of the next Meteor-up versions. You can run Meteor shell, and it lets you securely connect to the server. It lets you access a Meteor shell connected to the app running on the server. You can use this to run any code that you need to within the app. Another show that's coming to Meteor-up is the Mongo show. If you have Meteor-up managing the Mongo server, you can run Mongo shell, and it will connect to create a Mongo shell you can run commands in. This is useful to inspect the data, to explain slow queries, or to make sure the data is compatible before updating the Mongo version. An old command in Meteor-up, I don't think is too well known, is mup status. There's various components that have to be working correctly for an app to be available. We have the servers themselves and various software that runs on them. And when there's an issue, sometimes it's hard or time-consuming to figure out where that is at. So the mup status command automate some of the work. It checks each of the different components to make sure they're running correctly, checks for common misconfigurations or other issues, and outputs a report we can look at. But there's a lot of text depending on how many plugins you're using. So in MUP 1.5, there's a new option, the overview option. And this hides a lot of the extra information and just shows us the overview and any problems it finds. So here we see everything's running fine except Mongo. That keeps restarting. Maybe we updated it and it has some data is not compatible with the new version, or maybe there's not enough disk space or memory. We know to start looking into this to understand why there's an issue with our app. A new plugin I've been working on for Meteor-up is the Netdata plugin. Sometimes it's useful to be able to see how the server itself is performing or in the software on it. So Netdata is a popular tool for that. Every second, it collects between hundreds to thousands of metrics, and we can then analyze it in its UI. Or it can also send Slack notifications when there's an issue that it finds. And it's designed to be very low overhead. So the Netdata plugin makes it easy to set up Netdata when you have a large number of servers. You run a single command to install it or to troubleshoot any issues. And it has good defaults to reduce its overhead. Now I'm going to switch and talk about continuous profiling. This is a new tool I've been working on for Monti APM. Normally, when our app has CPU issues, we take a CPU profile on demand. But while the profile is running, our app runs noticeably slower. So usually you only take it for 10 or 20 seconds to avoid the effect it has on our users. But it works well when the CPU is constantly high, or there's some schedule to it being high. For example, there's a cron job. But other times it's random or is high in the past, and we want to, it's difficult to get a profile that covers that time period. With continuous profiling, it constantly profiles the app 24/7. Every 20 seconds or a minute, it finishes the profile and uploads it. So then we can go back and view the profile for any point in time, for any duration, to understand what was happening. And it's also designed to be low overhead. It makes different trade-offs than normal profiles do. So, and the implementation of Monti APM has less than 2% overhead, which is much smaller than most tools that we use for monitoring our applications. There's many benefits to using continuous profiling with our app. We can analyze anything after it happens. For example, during the night or over the weekend, we might have a large CPU usage increase, and we can go back and see what happened. Or if there's an incident, we don't have to worry about checking the profile during the incident to understand what happened. We can focus on fixing it, and then go back afterwards and look into what was going on. We can also correlate the profiles with other information. For example, if there's a high event loop blocks over time period, we can see what was happening. Or if you're looking at the method trace and there's large compute blocks that we don't expect, we can go and see what was running during those compute time. It's also useful for checking for regressions in performance. We might release a new version that's much slower, so we can go back and compare the profiles with the old version that's we already have and see how they compare with the new version of the app. And there's various other comparisons we can make. For example, we might increase the size of one server to see if it has any effect on the CPU usage of a CPU-intensive method. and compare it with the other normal servers. I'm going to show it. So this is the continuous profiler in Monti APM. It's still in development, so there's some rough edges you might see. But here we have a dropdown for the host we want to analyze. Right now we're looking at prod 1. And on here we have a CPU chart. This shows the CPU usage for every 2 seconds over an hour. So by showing it for every 2 seconds instead of the normal 1 minute, we're able to better understand what's happening and see patterns. For example, we see there's these spikes every so often, at regular intervals. And this is caused by an interval within the app that does some processing. Over on the side here, we see very high CPU usage for about 20 minutes. So if you want to see what's going on, you can click and drag, and it will download the profiles for that time period, merge them and trim them. So you have a custom profile covering the exact time period. And it provides us with various views to analyze a profile. These are very similar to what other tools for analyzing profiles offer, so you might already be familiar with these. The first one is entries. This shows where code started to run. For example, a timer fired or a request is received from a client. So then code started to run within our app from the event loop. So you have the name column that shows the names of these functions. This first one is run with environment. And on the side, we can see that was within the Meteor package. There are several numbers it gives us. We have the self time. This is how much time the function itself spent within itself, which here is 40 milliseconds. Then we have the total time. This is the self time plus any time spent by the functions it called. So here we see that one with environment spent 40 milliseconds, but including the time for the function it called, it spent 220 seconds in total. We can expand it to see what functions it called. We drop down to something interesting. Here we find this loop function that's within the Mongo package, and it spent 200 seconds. Many of us are not familiar with what all the code in these Meteor core packages do. And normally that's fine, you don't have to know because about analyzing a profile, but some of them are important like this one. So Monti APM adds a label here to help us understand what it does. It says receive upload doc. So every time the app receives an upload notification, this loop function runs to process that notification. So if you look at many of the other functions that were slow, we see that there's a lot of time was spent processing upload notifications in this profile. So if we see this in a lot of different places, a lot of different times, we see this issue frequently, then we know that we should look into ways to reduce upload notifications in our app or use something like what is upload so we don't have to process as many. There's another view that we can use to analyze this data and the entries, and that's the flame graph. The flame graph shows this graph. This is a very simple one. And each rectangle in the flame graph represents a function or a function in the stack trace. These map to one of the rows in the table we were looking at. So in the width is the duration, how long this function ran in total. You see the garbage collection was one function, and next to it is process timers. By going down, we can see what it called. So process timer is called record memory, and record memory called insert. And by looking at the empty space beneath it, we can see how much time was spent within itself or the functions it called. So beneath insert, there's nothing. So it spent all the time within itself. And the record memory, a little less than half the time is empty. So it spent that amount of time within itself. And most of the time it ran was within insert. So this helps us to easily see which functions spend a lot of time running. So if you look at the flame graph in Monti APM, it looks like this. So the very top are all of the entry points we saw. And by going down, we can see what functions they called. So zoom in. So here's the run with environment function. They called anonymous. They called evp.withValue. And here's a loop function they called. If you want to see what loop spent time on, we can look at the boxes, rectangles beneath it. You see a lot of time was spent in this promise.async apply. If we wanted to make loop faster for some reason, then we could look into this to see why it is slow. I'm going to change the view and select over here. Some interesting spikes in this section. Another view in the app is the hot points. This shows all the functions that ran in our app in the profile, sorted from slowest to fastest. This view is still under development, so some of the numbers are off. But so we look down here, there's a format property function that spent 1.5 seconds. So we can expand it to see what called it. So the format raw function called format property, and that was called by format value, which was called by inspect and called by dir. We see that dir is in the console. And expand again, we see there's a console call. So this is console.dir was called here that spent all this time. And console.dir was called by this function in our app called update stats. So if you wanted to reduce the time spent in logging console.dir, then you could look in update stats to see why it's logging so much. Maybe you could reduce how much it's logging or find a way to asynchronously log. And the last view is the timeline. If you've used the performance tools in Google Chrome, you might be familiar with this. This is similar to the frame graph, but instead of showing duration, it shows time on the x-axis. So this is useful for matching up the samples with any timestamps or other data. So you see in the CPU chart, we have these peaks in CPU usage, and they match with this busy activity in places. We can zoom in to see what was going on. So see here that it was within the update stats function. And go down and see that all the time was spent within console.dir, logging information. And these are broken up with garbage collection. There's many possibilities. So far I've been focused on providing the basic tools for analyzing profiles, but there's many ways we can go further from this. For example, we can provide special views for comparing profiles to make it easy to see what functions spent more time or less time, or which new functions appeared. This is useful for finding performance regressions in new versions. We also can automate analyzing the profiles to automatically suggest places that you should look into optimizing. And also, many times the high CPU usage is caused by code in our app or in packages we use, but other times it's within Meteor core packages itself. And that's usually a symptom of a busy oplog or how our publications work or how our methods work. And since many of us aren't familiar with Meteor's internals to be able to understand what it's a symptom of, we can provide tools to interpret it for you so you can understand what's going on within your app. If you want to join the private beta, I hope to release in a couple of weeks, you can let me know. There's a contact form in Monti APM. You can email me, contact me in the forum or some other place, and I'll be happy to give you access. I'm really excited to see what can be accomplished with these tools. They can make it easier to make your app scalable and more efficient. Any questions? Am I planning any update to the ELB plugin? Yes, I am. I was working on an update last month, but I got distracted with getting ready for this conference. So now that this is done, I probably will be resuming work within the next couple of weeks. Any other questions? So question about how this data is being collected and processed. At the moment, it's pretty simple. We create a profile using the V8 profiler npm package, but we have a very low sampling interval. Normally, profiles take between 1,000 and 10,000 samples every second, which adds the overhead. Continuous profilers usually take between 90 and 1,000 samples a second. So you reduce the overhead and collect less data, but still is plenty to understand what the app is doing and identify the bottlenecks within the app. I think in Monti APM right now, we take a little over 100 samples every second. The continuous profiler is currently not available. So there's a few things I need to finish, but I plan to have a private beta within a couple of weeks. Let me know if you're interested. And once I know it's working well then and useful, I then will release either a stable version or a public beta. How can you control and sticking samples? At the moment, you just turn it on and it runs constantly. It would be possible to turn it off, but it's designed to be lightweight, so there's not really any downsides to it constantly running. Is there a reason why you wouldn't want to have it constantly run? Recommended resources on improving Meteor performance. The Cadora used to have an academy that was very good. They also had Bulletproof Meteor. I think their website is down right now. And there's an older book. I forget the name of it at the moment, but it's about Meteor's internals. But there's not much up-to-date information. That's one of the projects I have planned. Is I'm going to be spending a bunch of time on experimenting to see where the bottlenecks in Meteor are and documenting them and updating the Cadora Academy. Thank you for listening.